Hello friends, welcome to my YouTube page. My name is Sahil Vasani, ISO lead auditor, Lean Six Sigma specialist, and an ERP consultant. Today I'll be taking you through statistical process control part 2, in which we will be talking about analyzing and collecting data. Make sure you stay tuned in for that, and make sure you like, subscribe, and comment down below to show your support and just generally any questions you have for all these topics that we are talking about. So as we saw last week, that there are 5 core tools, and I will not be going through all of these in this particular video, but make sure you do subscribe for a future video in which I will be taking you through all of these particular topics. We will be getting right into collecting the data and recording it. So once the data is collected, it is then converted into information by putting it into many charts. And I will be talking about these charts in a future video. So make sure you have subscribed to my channel. But the best way to use this data is by using the correct charts, as different charts have different requirements that must be followed to gain maximum value for your data. Now, this is an example of a control chart, and it is used in the control process. It's called an X stroke R chart, and it has different levels of control limits. And this is such as the upper control limit, the lower control limit, and the center line, which is the average of all means. So the blue line running in the middle, which is right about here, is derived from various means which are retrieved from the data itself. Okay, so this is that particular line. And this chart is mainly used with variable data. Now, this line here is the upper control limit, and this line here is the lower control limit. And this line here is the center line, just to give you more information on what that is. There are now different types of data. There are 2 types of data. The first type of data being attribute data. This is data which is discretely observed. Remember that, friends, it's discretely observed. It can be in the form of an integer or a whole number, and we can take an example of a company producing pens. Okay, so imagine that the company producing pens have passed from the QC inspection. Okay, so there are different number of pens that are passing from the QC inspection, and these pens which are failed or rejected are counted in whole numbers, and it is determined whether it is a pass or it is a failed. Okay, now there is the second type of data, which is the variable data. Now this data is continuously measured throughout the process of the production stage. It is usually in the form of accurate data. And another example of this data is that we can take the example of the same pen which I previously talked about. If the outer diameter is supposed to be 5 millimeters, okay, and you take a vernier caliper and measure each and every outer diameter of that particular pen, then that becomes variable data. Now, obviously, the variable data can vary from 5.00, 4.98, 5.02. So that is what you call variable data. Now, I'm going to take you through the hierarchy of selecting a control chart. Okay, this is very important. The first step is to decide whether the data is variable or attribute data. Okay. So if it's a variable data, you have to then select the sample size for the variable data. And if it is n is equal to 1, then you will select an XMR or IMR chart. If it's between 2 to 10, you'll select the X bar R chart. And if it's greater than 10, you will select the X bar S chart. Okay. Now let's go to, if we go with the attribute data. Now here there'll be different sample sizes, and there can be a multiple, or they can be multiple or single. But anyways, let's see the first one for multiple. And if the sample size is constant. So if the sample size is constant, you will select the C chart. And if it's not constant, you'll select the U chart. And on the other side, if it's single number of defects per unit, then you will select the sample size as constant. If it's yes, then you'll select an NP chart. And if it's no, you'll select a P chart. Now, when we are analyzing the data, we see that the data can fall between the two control points, or it can fall out of the control points. The first data that we see is usually when we see the points falling out of the UCL or the LCL. And this has its own implications that the process is not being efficient enough. So in this case, there are also different causes of process data not being able to be within the limits. Okay, so the two causes are, the first one being a common cause. Now, a common cause is generated from usual machines that have tool wear and tear as an example and can cause a process to be interrupted. So for this, we can look at the kappa model, which I will be making a video in the future. So please subscribe to get a glimpse of that video. I will be making it very soon. Now, the second type of cause is a special cause. These are causes which we cannot predict within our process. An example of this process is a machine malfunction in the PLC of the machine due to a surge in electricity. So these are unpredictable events that cause our machine to have a lot of downtime. Okay. Now, once the data has been collected, then the operator can inspect all the control points and use kappa to prevent these causes from happening again in the future. This will ensure the requirements are being met, and hence the process will continue to be effective and also efficient. So I hope you have understood quite a bit from this video. And this is the end of this video. I sure hope that you enjoyed it as much as I did, because I really love talking to you guys. I will be dropping a video next week explaining about the different types of charts. So please make sure you stay tuned in for that one, and please press the bell notification so that when I do make a new video, you are always in the loop that the new video has come and that you can start watching it. But thank you so much for your time, and I hope you did enjoy this and use this information for your own personal purposes. Thank you so much.